And we are live, and welcome to Teaching Tip Tuesday. My name is Michelle Williams, aka the Ignited Teacher. I'm here on social media, which is Twitter, Facebook, YouTube now. And I am so glad that you decided to join me tonight. Teaching Tip Tuesday is a 30-minute show that I put on every Tuesday night at 8:30 p.m. to 9 p.m. Central Standard Time. And what I do here on Teaching Tip Tuesday is I help math teachers of struggling learners, which may be 504 students, special education students, and students that are generally behind in mathematics, to increase student achievement and to effectively manage their classrooms. And I do that through classroom management strategies, good math instructional pedagogy, which is instructional strategies, and project-based learning, response to intervention, and technology integration. So that's what I do here on Teaching Tip Tuesday. And if you're new here and you can't catch me live, you can definitely catch me on the replay. If you're on Facebook, Twitter, unless the platform deletes it or you have to find it, you can either get it through my email list, because I send out a link to the actual um, post on social media, or you can get it on a replay on one of those platforms, either Twitter, Facebook, and YouTube. You can always find it there if you so choose to. So, like I said before, if you are new here, thank you for tuning in. And if you have been watching me for some time, thank you for showing up and supporting my Teaching Tip Tuesday. This has been a long journey with me. I know if you've been on my platform any amount of time, you know that my live streams have changed. I look back at my older live streams and I laugh because they're so different. I started out real simple. So I know some people are like, you have all this stuff going on? Yeah. And I am a tech person, so it just gets my little fillers going. So tonight we're going to go ahead and dive in. And tonight's topic is about conceptual understanding being the pathway to procedural fluency. So there's a debate about conceptual understanding, and some teachers, especially at the elementary level, conceptual understanding is sometimes on the back burner when it comes to moving student achievement. A lot of, especially in third grade, when as it pertains to equivalent fractions, I know that butterfly thing, that blows me. And I don't understand why third grade teachers, well, yeah, I do understand why they use it, because it's a quick fix. But in this article called The 13 Rules That Expire, it is written by, I don't think it's written by NCTM, but then again, it may be. If you look that up, they call it The 13 Rules That Expire. So what it talks about is how some teachers teach skills for certain grade levels, and then what happens is those skills can no longer be used at other grade levels. So that's why they say they expire. So that butterfly method over time will expire in fourth grade, because they get to comparing fractions, and comparing fractions is definitely a conceptual to an abstract concept. So where the children are in their process, whether they're at the algorithm, which is the procedural fluency, or at the conceptual level, it matters. And why does it matter? Because the goal is to take the children from concepts to moving them to the abstract, which is the representation of the concept with the algorithm. And a lot of teachers don't understand that that algorithm is it tells you what's going on in a shorter form with the concept. And the way that I teach my students to know the difference is that, because some of them are like, well, can I draw a picture? Well, here's the thing. As you move through math curriculum, and this is a no-brainer, we know that the children are going to need to move to a more efficient way of solving problems, which is moving them to the algorithm. I had a little boy, I'll never forget. He used to say, Miss Williams, is there an algorithm for this? Because he never wanted to do the concept because they had to draw pictures and they had to explain what was going on because it cemented that algorithm. And when they made mistakes, they could go back in the concept and analyze their own mistakes. And that's why I say that conceptual understanding is the pathway to procedural fluency. So I'm going to reference a blog post from my website, and it's called, well, the website is fuelgreatminds.com. And on my blog post, I'm going to show you, let me share my screen right quick. It's not sharing. Let me share my screen. Oh, I need to unlock my screen first. I do not want to update. Okay, there we are. So this is on my website, and I just did an update, and I really, really love the update. It's great. So all my stuff is categorized on my website. So you have math instruction, then you have project-based learning, all the 5 topics that I cover, technology integration. So you click on math instruction, and it takes you to all of the math blog posts that I have created. And the latest one, which came out last week, was this one. And it has pictures on here. So in this picture, I think this picture may be 5 years old now. So she's probably in 10th grade because she was in 5th grade when this was taken. But notice in this picture, they're working in groups, but what is happening here is they are actually using manipulatives to solve the problem. So when I teach, because I was teaching 5th grade at the time, when I teach this, I generally teach it side by side with the algorithm and the manipulatives. Or if I am further in my lesson, I'll have them draw it and then split the paper and draw and write out the algorithm. There's a um, I think it's Kagan that does Rally Coach, and they have partner A, partner B. Well, partner A will coach them through the concept, and then partner B will have to do the algorithm. So just different activities like that to make sure that the algorithm is cemented in the student's mind as well as that concept, because they go hand in hand. And I know a lot of teachers are saying, well, we have STAR testing. That's the name of the test in Houston. Well, that matters not, because what happened with STAR, they changed it to where they test the kids' conceptual understanding as well as the algorithm. So in 5th grade, they have problems on there that test their conceptual knowledge, and then they have the part where it has the algorithm. So if the children, and I figured this out by trial and error, if my students only got the conceptual problems right, which is the pictures, they could not score meet on the test because that basically let them know that they were not hitting those readiness standards. The readiness standards were the um it was the I lost my train of thought. It was the algorithms that they had to master. So in order for a student to get meets in the state of Texas, they had to get the conceptual problems right and the algorithm problems right. And if you look at your STAR um, report, it shows you whether that student got how many they got right, but it doesn't show you how many of each problem they have right. But on the blueprint, it does break it down and tell you what is going to be on there, and you can tell by each teak how many problems generally that's going to come from that. Because I know the readiness standards in the state of Texas is the bulk of the test, because for like fifth grade it was 67% of the test. So it meant that my students who had not made the jump from conceptual to the algorithm, 9 times out of 10 was not going to meet standard. They were going to be approaches. But if my students made that jump, I knew that I could get them to meet. That's why the conceptual part is so important, not because of the test. It cements that algorithm. And when the algorithm, like some of the kids mess up, they can go back and really, because the brain thinks in pictures, they can go back and see where they made a mistake. So that's the first picture. Also here, I am a math interventionist. If you see here, this is in my 9th grade high school class, and you can see those fraction wheels. So we were reviewing equivalent fractions, because fractions is the gateway to algebra. I'm telling you, it takes every type of fraction and put it in to those equations. And when the kids started having to do fractions, and a calculator can only help you so much with fractions unless you're going to convert them to decimals, but that's not good practice. It really isn't. I think it was a math professor that told me that fractions are more exact than a decimal. And I had to think about it. I was like, I guess they're right, because when you're talking about a decimal, you're talking about out of 100, multiple of 10. So you can't, it's not going to be exact, which fractions are more of an exact measure. So I don't teach my students to get into a habit of converting things to decimals to make it easier for calculator use. But in my math intervention class, um, we had the magnetic fraction wheels, and my students actually used them. They went to the board. As you can see, I have a 10 frame as well up there, but they used those to check their algorithms when they were creating equivalent fractions, because they could move the pieces and stuff. So it really helped them and cemented that algorithm part, and helped them make the jump, and gave them a more of a support that they could do it independently without calling me over, because they could check back with the conceptual part. And then we have this here. Now, there's a continuum that children are on. This is one of my little babies. She used to struggle in math, but she was a really, really hard worker. But when we used to do Flipgrid videos, and I would give this to them, and they would have to um, solve the problem. My higher level kids, they had to do the algorithm and the actual, they could do decomposing or they could do fraction wheels. So I gave my kids some parameters which they had to work in. And this student, I knew she had not made the jump from the conceptual, which she did here in this box. She did show that she added all the wholes, and that half was left over. And that was a form of an algorithm. But is it the traditional algorithm? No. So my thing was, we were still pushing her to where she could just multiply, understand that because this is repeating, and if something repeats, it can multiply. And then you just add the 1/2. So that goes back to that multiplying the denominator times the whole number and adding the numerator. But she was close enough to make that jump. And she actually, over time, by the time we finished this, she was able to just multiply and add. But it is a process, a thought process. And I don't care how um, I mean, I don't, your test does not dictate how long they're going to take to actually make that jump, which is sometimes difficult for students. Let me go back to here. It's sometimes really difficult for your students. I think my comments are not coming up because I see some stuff on. Okay. So that's that conceptual understanding. When I tell you, if you're trying to make sure that your children or students are proficient with the algorithm without mistakes, they have to master the conceptual understanding. I know there's going to be some naysayers out there that say, well, my kids, they do it without, but there's really not an understanding of the why it happens. And I've seen it because I've taught elementary, middle, and now high school, and I see how children do rote mathematics. Well, my teacher told me how to do this, but why are you doing that? It doesn't make sense. How can this, and it goes back to the mathematically proficient student. If a student can't explain why they're doing something and how it relates and apply it to different um, situation, and definitely real life, because that's one of the proficiencies that they said where a student has to be mathematically proficient, that they have to be able to find the value in mathematics. And a lot of the students don't, especially struggling learners, because teachers tend to focus on they have to get this right. They have no, but take them back to that conceptual understanding and find out where they are in that continuum, because either they can be at the beginning, the little girl that the last picture that I showed you on the blog post, she was almost there. I could tell by her work, because students that are not about to transition or haven't are not in the process of transitioning to the algorithm, they cannot even write a simple or create a simple algorithm from the concrete model. They can't do it. So she was close to transitioning, and when you're in your small groups, these are the things that you're looking for. Where are the students in that continuum? You have to know what your standard or your objective or whatever it is that you're following. Are they meeting that standard? And for me, with the converting fractions greater than one whole, she was close to it. So what it does, it helps me to make instructional decisions for her, especially as it related to math intervention, because I knew if she got that concept, she could get adding fractions with unequal denominators, because we had to convert those answers, if they were fractions greater than a whole, to a mixed number. You could not leave it as a improper fraction. So that's one of the things that I was looking for in our work. But I think as teachers, we don't take enough time to analyze our student work. We're so much on the go and giving them all of these problems to bog them down. And it's not about that. It's about working smarter, looking at the student work, and making sure that the children are going into the direction. Now, that student, she was in my small group when fifth grade until the end of the school year. And she made significant gains. I'm not sure what she actually did on the test. I can't remember. That was 2 years ago. So, but she made a lot of gains in mathematics. She really did. And she started to enjoy math because it started to make sense to her, and she could talk about it and not feel like she's grasping at straws, because kids that struggle, they are the ones that are always saying, okay, well, they take every strategy that you give them and start mixing and matching and hoping something falls out of it. So that's what why I say, if your students are struggling with algorithms, take them back to the conceptual model. Make sure that they're rooted in that, and then try to move them to the procedural fluency, which that is the goal for procedural fluency, especially in the upper grade levels. Fourth and fifth grade, the goal is to get them to that algorithm for middle school, because with these new standards, and I know some states, well, we don't do Common Core. Well, your version of Common Core, because they're all doing it, those standards, they in sixth grade, they're transitioning the children to algebra very quickly. And when they're not sound in those algorithms, the kids struggle. I can tell you, as a former middle school teacher, when my kids did not come with division, some of them got left behind because they couldn't make the jump to the standard algorithm, not the hangman algorithm, the one we did hangman math. No, that doesn't work in middle school. They call it a standard algorithm for a reason, because it's what everybody uses. And I think there's this myth around math in elementary, but it's okay. The kids know it's not okay, because you're setting your children up for failure in secondary. I get it, it's great for elementary, but you have to wean them off of that, like you wean your children off of pacifiers. And like, if you don't have any children, you're animals. Like when I first got my dog, I had to crate him. Well, as he got older, he was able to stay out and not chew up everything. So it's a constant process of weaning. And by the time they leave elementary school, they should be proficient in those four operations, and being able, I know for fifth grade in Texas, they have to be able to apply it to different concepts. That means decimals and fractions. They have to be able to do those four operations, because we do dividing whole numbers and fractions, and we do multiplying whole number and fractions. So they have to be proficient in that, and those start with conceptual models. So if you're not on my wait list currently, you can sign up, because my Math Intervention Academy will be launching July 15th. I am so excited. And some, like the tips that I write about in my blog posts, you will have access to me to pick my brain. I had one of my former colleagues, she texted me today. She was like, "Can I pick your brain about some math?" Sure. So you will, if you need support with your instructional strategies, and that's one of the things that I get asked all the time about, how do I teach this? What's another way to teach it? You'll learn that in the Math Intervention Academy with me. And then we have a community. There'll be other teachers in there. Also, I will be helping with the transition, using technology to support your struggling learners. That's one of the things that I found that had a significant impact on my special ed population. Sometimes they need videos that they can play over and over again, because they don't have the retention, and then there's gaps. They can go back, and you can teach them how to reference certain material. I also teach about Google Classroom, how to use that as a tool, using Nearpod, those things like that, setting up your small groups, how to transition your students in and out of those groups based on things that I currently do in my classroom. So if you're a new teacher and you're not familiar with me, I am still a classroom teacher. I am a math intervention support for Algebra 1. So if you don't know who I am, that's what I do. I'm not telling you to do something in theory. It's not theory without practice. These are things over the course of my 20 years of experience, and I've taught math. It's been 16 years that I've been teaching math. And these things work for students, because they work for students and I've done it with kids at the elementary level, and it works at the high school level and secondary as well. So if you're not on that list, you can go to the mathinterventionacademy.com and get on the waiting list. And I will, because I don't think I'm going to be doing much marketing for it. I'm really going to be trying to get people who are on my email list first in, and then I'll start as time goes on, I'll do more marketing. But this first time around, just out the gate, it is a beta course. Well, not even course, membership. And it's a beta membership. That means that we'll be building it together, and you will be a founding member of my um, Math Intervention Academy. And to be honest with you, it's one of a kind. There is not any other membership that is like this. I've looked. There are other people who focus on just math strategies. This is getting those students to move. So if you work at a school where your kids are working below grade level, and you know what, that's who I specialize in. I tell them, give me my little low babies and we're going to work it out. And that's what we're going to do. So, and we always make gains at the end of the school year. Before the coronavirus, my students' numbers start moving. And they really couldn't believe, yeah, like I was working with them. We started to see some positive progress with those students, even with behavior and really just working with them. But you have to have a heart for it. And that's in the foundation module. We'll talk about grasping and connecting with these students, because these are the students that have the most issues. If you're a new math intervention, then this membership will be for you. So that's all I have for Teaching Tip Tuesday tonight. Thank you for joining in. And if you're watching on the replay, definitely leave your comments in the comment sections. If you have any questions, you can definitely leave those as well. And I'll see you all in my next live stream.